welcome to my workshop. For the new year 2017, I'm going to introduce a few more segments into my channel, and it's all really CNC related. And the first one that I'm going to introduce is one that's probably going to help a lot of you guys out, because a lot of you are asking me a lot of questions about the most recent videos that I put up about grayscales and where to get them from and what have you. There are people out there selling them. So I think really to take me into a new realm, and I want to bring you along with me and save you a bit of money as well, is I want to go into the realms of 3D scanning. That is 3D scanning an object, any object really, from a whole person to an object. If you want to convert this object to a 3D file to either 3D print, now that's another subject we're going to go into, because I've actually got a 3D printer on order as well. But more in line with what we do with CNC routers is to make this into a 3D relief via a 3D scanner. I'll just cut you to a bit of video showing you exactly what I did. It's a very temporary, shall we say, R&D project to find out why I was getting such a crap scan. I sort of, in using it, I found if I could keep absolutely still with it, there was a far better scan. So rather than me holding this and trying to move around an object to scan it in, I got my wife's, I think they're called Lazy Susan, the rotisserie thing out of the kitchen, and put an object on it, floodlit it, and well, you'll see in the clip, actually put some electrical insulation tape around this and connected it to a clamp, and just made a makeshift holding device out of an old lamp I've got, and it worked perfectly. I mean, it was like 200–300% better scan by holding that still and rotating the object. So that's the classic reason, I suppose, why they have an enclosed body with a rotating table and the scanner still. So what we're going to do with this segment, this video today, is we're going to build a rotisserie, shall we say, a rotating table. I've got a Lazy Susan bearing from my local hardware store, Bunnings, and we're going to make a rotating table to further develop the concept. Okay, so I've just cut my melamine sheet now in 2 halves, so it's 600 by 600. So what I need to do, this is going to be the bottom, so I'm going to do a 300 millimeter radius arc from here to here, to just cut out the back and keep this square on the front. And the way you do it is very simple. This is a trim router with a 5mm cutter in, and I've just extended this with a piece of cardboard actually, and I've got my rough radiuses on there, drilled a hole in the center, and in this case it's 300. Let's get a screw. So what I've done, I've set the router 3mm depth out of the router tool, and we're going to do about 4 passes to get this cut out. So raise the router up, switch it on, and then rotate round cutting. We just repeat that process about 4 to 5 times, just taking the router tool down 3mm roughly per sweep round. I can mount my backing board here to the base. I'm going to be mounting it with 14mm staples with my air gun. So all I've really got to do is clamp one corner here, if I can. Continuation of setting up this rotary device for scanning a 3D object, or making a 3D scanned object and put it into a computer. Now the scanner that I purchased is an XYZ printing scanner unit. Now I've done some preliminary experiments with it, and what I have found with it is you have to, let me see, you need to definitely keep your hand very still, and say this was the object that we were scanning. You sort of scan from here up like this, and you've got to keep the angle just about right and be very steady and deliberate with your movements, otherwise it doesn't scan. So I'm putting this together to experiment with different types of lighting, incandescent light and fluorescent light, and I've also purchased an LED type floodlight, and which illuminates quite well actually. Let's switch it on, there we go. Illuminates quite well, because what I found is different types of light and different intensity affects the scanning a lot. So we're going to find it the best method for scanning an object. In the specifications that's required for this system, it states Windows 8.1 above, so anything below that is not going to work. 32 or 64-bit operating system, that's fine. And a minimum of an i5 processor. Well, I wanted a scanner to be totally portable, so if I wanted to walk around the garden and scan something, I can. At least that was the idea. So with that in mind, with having it totally portable, Maria, my wife, purchased me a brand new, state-of-the-art Hewlett & Packard 1 terabyte. This is an i7 and it's a solid state, so it's more than capable of doing everything that is demanded of it. And I've done a couple of preliminary scans and it works just fine. However, I will say the program that's provided with this, I couldn't get on with it. I didn't like it at all. So I downloaded another program which is free of charge off the internet, and I'm going to see how I get on with that. And if you know, I will rate it for you. And if you know you fancy getting it yourself, well, I'll put a link down below so you can go and get it yourself. Okay, so let's start scanning something. Incidentally, I wanted to, I am eventually going to motorize this, and in preparation I've got a motor with the gearbox I think I showed you the other day, and I've already put a some sort of wheel on it with a rubber drive to be able to drive on the outside of here, and also a variable power supply to drive it, so I can vary the speed, just have it crawling or stopped or started or whatever. So there's a power supply for that. So I've got everything necessary to do it. I just want to be sure before I do any more work that I'm on the right track here, and I'm pretty certain I am. So here, also what I did, I'll take the camera off for this. Also what I did, I just marked out a piece of wood and cut it on the bandsaw to fit this over firm like that, so it holds it nice and firm. And of course I can extend this up to, I think, 250 mil, so I can actually see the top of this particular object. This was provided by my granddaughter, and somewhere around here I've got a pink pig, and that was provided by my grandson. So in actual fact, matte green, this matte green is a perfect color to scan, for the scanner to pick up, but it doesn't particularly like black very much, I've noticed. Right, so we'll get some illumination on Froggy. That should be fine. Right, we'll open up the program. A lot of you will know this program. Very reputable company. You must have the camera actually plugged in before you open this program, otherwise it just won't. It'll say that it doesn't recognize a suitable device. And there's Froggy. Okay, so this Froggy and we're going to start the scan, and I'll just turn him very slowly. Not really interested in the back of him, but we'll see if it'll do a 360. You see how it's going lighter green? And I have noticed too, with a rounded object like this, it does just leave a patch that doesn't scan very well. Don't know why. That didn't bother us anyway. Okay, so I've done a full 360 there. Now I'm going to raise the camera up and reposition it to get the top of Froggy's head and eyes. And turn Froggy round. Notice the eyes are a bit speckly because of that black, but within this program it will actually fill that in. Oop. So I went a bit too quickly then. Got to allow the program to keep up with the turning of the object. It sort of follows the object. Bear with me a little bit. Take it all the way around. Now this program will fill in some of the blank spaces. Okay, so there's a full 3D rendering of Froggy, and we're going to say finish. And it should automatically come up. This is an excellent program, and it is free on the internet. I do suggest anybody downloading this program because it's good. And there's Froggy. And there he is. You'll notice he's this is for 3D printing setup, but we can manipulate this. Now I'll show you what I mean by manipulate. See this holes in the eye area here, and a little bit in the foot there, and of course underneath is hollow. So what we can do with Froggy is use one of these tools and go solidify. In other words, make him solid. Fill in the blank spots, and there it is. It's grey. You'll see it's grey, but colour really doesn't matter. I'll show you. It's just showing a rendering. It's filled in the base as well. This is for 3D printing. Now I could save this now as an STL file and put it into Cura, which is a program to slice it for 3D printing. Or I can save this as an STL file and put this directly into ArtCAM. But what we can do for ArtCAM or Cura is go that. We want it saved that. You'll see a lot of models saved as gold or green or some other colors. This particular program saves it as a blue model. Now you'll see it's got a couple of little lumpy areas, but basically the object is there, and we can put that into ArtCAM and just clean up these little areas like you have seen me do on I think the previous 4, 5 or 6 videos. There's at least 4 of those videos that show you exactly how to clean these type of reliefs up in ArtCAM. And you could either, in ArtCAM, you could treat this and cut this as a 4th axis on your CNC machine and have the object there in any particular size that you wanted. Or you can treat this in ArtCAM and basically squash it up, lose the back, cut it in half, lose the back, squash it down a little bit if you wanted to, and just have the 3D relief as you normally would. So there's a very quick I suppose demonstration of how to make a 3D relief. So we've just touched on the subject of 3D scanning and why it's necessary, I suppose, if you really want to provide your own 3D reliefs. If you can't find base material on the internet in the form of grayscales, and I've shown you in previous videos to this how to handle them, well, you can quite cheaply, this I believe is just a little over $200 US. You know, it's really a bargain. Apart from the program that comes with it, I don't like it. I couldn't get it to operate like this program. This program is free off the internet. I'll leave a link down below where you can download it from. It's very good, but this 3D scanner, camera, whatever you want to call it, for the money, I don't think it can be beaten. It's very good. Obviously, you get what you pay for. I don't know what sort of lifespan it's going to have, but certainly it does a half reasonable job that I'm quite happy with, so I can say that for the money I can recommend it. And incidentally, I am not sponsored by either of these companies. What I'm trying to do is provide you with information that might save you a bit of money. What I'm interested in is, I suppose, promoting my brand of machinery, the CNC rotors, Pacific Tooling. I'll leave a link also to Pacific Tooling if you're interested in good CNC rotors. A lot of you out there are asking me what's so different about the CNC rotors that I'm providing. Well, it's like chalk and cheese, and there again, you get what you pay for. If you're going to buy a machine for $2,000 to $3,000, then that's what you're going to get, $2,000 or $3,000 worth. And for a little bit extra, you can buy a decent quality, industrial quality machine. And if you want to know what's in these machines to make them so different, go to my YouTube channel, click on videos, or scroll down and have a look at 143, 144 and 145. That will show you exactly what goes into Pacific tool machines. And one major factor, actually one of the major factors, that the entire machine is built on a rigid cast iron chassis that's over ½ inch thick. and it's precision machine. Then everything is built onto that. It doesn't flex. The gantry is solidly cast aluminium. It doesn't flex, and it all runs on Taiwanese imported ball screws, an inch in diameter for the X and the Y, and also X, Y and Z are linear rails. For a little bit extra you can upgrade to square linear rails, but the standard models come with round linear rails, and look, they are absolutely fine and perfect. It's just that some people prefer square linear rails. That's fine too. So please have a look at the videos I've just mentioned, and have a look at some of my other videos, and please tell me what you think. And well, for this video, I think that's about it. And by the way, before I go, hopefully tomorrow or possibly Wednesday, I should take delivery of my 3D printer, which is an Anit A8, which is a kit form. So I'm going to be putting that together, and I'll do a little bit of a video showing that, and we'll see how we get on with the 3D printer, because it's an item that Pacific Tools are interested in moving into. So you could follow me on that little bit of a journey too if you like. So bye for now.